Record. Okay. Plug my computer in because I'm still uploading the recording from the other class to YouTube, which apparently uses my local machine's processing power and not the YouTube servers, which I guess makes sense because I'm uploading it, but still kind of annoying. So I apologize for any choppy frames. So I've got my dungeon here, and I'm going to start dividing it up. I'm going to put one line going across like here. I'm going to put another line going across here. And these are just mostly random. I'm just kind of looking at where my stuff is and just thinking, okay, like here's kind of a natural point. Maybe here's kind of another natural lateral line. And I'm going to do this all the way across. They don't have to be even. Not to be even if you don't want. Just kind of... Basically what we're doing here is we're taking this dungeon, and because I don't want to pixel by pixel generate all of this like some of you maniacs did, instead of having to like go through and pixel by pixel generate this thing, I'm abstracting my map into these general squares that will describe what's there, and I'm just going to use a key system to be able to describe the specific rooms. So honestly, this is probably the hardest part of the project. In terms of describing each room, that is, I'm going to argue that that's probably the easier part. Oops. I should put that over here. That's not straight. Put that over here. This one like that. That's not straight either. There we go. Okay, and then I'm going to put lateral lines. I'm going to put one over here. And maybe let's make one over here as well. And I'm not going to populate the whole map, don't worry. I'm just going to go through a little bit. So I'm going to put another one over here. And another one over here. And you guys kind of get the idea, right? We're going to go the other way. So next, I need to fill in what each room is. So I'm going to look at this and I'll be like, okay, maybe we'll make this be the entry point. This is where the character starts. Here's a hallway. This will be room 4. And maybe this will be room 4 as well. I want to make room 4 2 squares. Here's going to be a hallway. This will be room 33 from the map. And obviously, you know, like it's up to you what you decide to name these. I'm just going off my map. These are very clearly hallways. I need a hallway here so I can get into this room. So I'll put a hallway like that. And maybe room 29 will be all along here. 29, 29. This is all the same room over here. And maybe I make these room 29 as well. Make it a nice big room. Hallways over here. I'll put a hallway over here. I'm going to just decide to put a hallway over here as well. And then room 30 will be 1 square. And then hallway, hallway. I'll leave that one empty. Hallway, hallway, hallway 31. Again, I'm just kind of going freeform through this, just looking at my map and being like, okay, this is what I want here. This is what I want here. You know, maybe we'll make this one be a room. Hey, you know what? It's not necessarily in the drawing, but I'm going to make room 26 be 2 rooms. And you guys get the picture, right? I'm going through this whole thing. And is it okay if I draw my own map? Yeah, I mean, if you don't want to use the generator, that's totally okay. I recommend using the generator because it gives you a better, clearer idea. It's easier to draw over the generator like this. The problem with writing your own map, drawing your own map, maybe you run into some stuff where it becomes harder to represent that in the 2D array. But if you can make it work, you can make it work. I recommend going through it this way because it abstracts your dungeon in such a way that it'll be easy to apply. It'll be easier to go on to the future steps. But this, I think, from what I have for the whole project, I think this is like one very clean way. You guys might discover other ways that are very clean and very efficient, but this is what I liked using. And this is what I would recommend to other people how they go about. Just loosely define some lines, kind of put your definitions of the rooms in every place, and then just make this into an array. And you know, you can make these lines a lot bigger in between, like in your grids, you can make them a hell of a lot bigger, so you don't have to have a huge ass array that you have to hard code populate. But that's kind of the main. This should be like I think the biggest, hardest part of the project. I think the logic of saying, okay, can I go right, left, or can I go north, south, east, west? Like finding those directions should be a lot easier than it should be this. One tricky part might be coming up with the logic of, well, how do I know if the way I want to move is out of bounds? So that's something you guys will have to check. You guys will have to figure out on your own. But this is kind of what I encourage you guys, the direction I encourage you guys to move. Does this help for those of you who might have needed help? Those of you who might have questions, now is the good time to ask questions. Because if everyone's solid on this, and after this everyone's got a good idea what they want to do, I'm just going to go on with today's lesson plan. And I won't be taking any more time during the class to talk about this. So this is your time. Print map. Okay. All I expect from the print map is something like this. When you print it out, it should just be this. Whatever internal map you're using, I want to be able to see it. Basically, however you decide to draw your map and apply it into a thing, that's what I want. Just visually messes with me that lines of wall and room match up with the array lines that you have set. Yeah, you don't have to draw walls. The walls are more of an abstract concept that come from the rules we've established that you can only go from a hall to a room or a room to a hall. Like, for instance, with room 33, I can move between these two. That is allowed. That is okay. But I couldn't go from, like, say, room 21 to 29. That is not okay. Or sorry, this is room 29 as well. But you get the idea. I couldn't go from, like, 29 to 30, for instance. How would you distinguish which hallway the character is moving to? What do you mean? So let's say the player is right over. Let's say the player is right here. Okay, in my game, the player is right here. My game is going to tell him you are in a hallway. There is a room to your west, a room to your north, a room to your south, and the hallway continues to your east. If they go east, they'll say the hallway continues to your west, the hallway continues to your south, and there's a room to your north. If let's say they're somewhere like here, and there's a hall here, here, and here, it'll just tell you, hey, there's a hallway to your west, north, and east. And then to the south, the room continues. That is how your game should go about it. Obviously, the first line should be something like, you are in a room with blah, 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 blah. It looks like blah, 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 blah. And then describe, there's a hallway to your east, to your north, to your west. If anyone's ever played Dungeons and Dragons, it's very, very similar. And Anthony, yes, you can go from 29 to 29. He might in your game, but ideally what should be happening, yes, Juvenile, you're putting rooms in a 2D array. You're putting rooms and hallways into a 2D array. That's how you build your map. Ideally, what should happen is each step, the game should tell your user, hey, you can move in these directions. Like if I'm here in room 30, my game will be like, you can go east or you can go west. South, there's nothing, so you can't go there. North is a room, so we're saying there's a wall, so you can't go there. Or north is a different room, I should clarify, so you cannot go north. So you can either move east or west. That's it. Does that clarify some of the questions you guys might have had? Making things a little more clear?
Wait, so if we're in 30 right there, why couldn't we go to 29?
Because of the project requirement that you can only move from a room to a hallway. You can't move from one room to a different room. You're going to pretend that there's a wall there.
Oh, okay, I see.
For the print map, yeah, all I really want is for, like, the print map doesn't have to look user-friendly. It just has to be whatever your internal implementation of your map is. I want to see that. And all I ask is that your map makes it clear where the player is, and you can talk about the print map method in your documentation. Let me know, like, hey, in my map, I have a P for the player. Right. I just want to be able to see, where the different rooms are, where the hallways are, and make sure I can't break your game's logic. Like, let's say I'm in room 4 and I see, oh, hey, there's a room 29 here. I'm going to see if, even though the game didn't give me an option, can I go south? Your game should be able to tell me, like, hey, yo, you can't go south. There's a wall there, right? The map is literally just there for me so that I don't have to use the debugger tool to track how your how your 2D array is changing constantly. It'll just be easier for me to type in map in between every iteration than to have to keep using the debugger tool and going back and forth. Yeah, Brandon just sent me a message saying, conceptually you have me, but implementation will kill me. Welcome to development. That's really what we struggle with every day as developers. Conceptually it's easy, but the implementation is where things get kind of dicey. So you guys do your best. If we'll see. I really am hesitant to give more extensions on this because we really do need to get moving with the rest of the project. Are we going to use objects and classes for this? Not this specific milestone, but the next milestone will involve objects and classes, yes. Basically where we're going from here, kind of the last milestone is going to be, you're going to translate your whole game with objects. So you're going to have objects for your monsters and your minions. I'm going to assign that next week, and then you'll have through Thanksgiving break and probably the week after to work on it. And then for finals week, you guys will be submitting your final submissions.
Wait, so milestone 3 would basically be milestone 2, but with objects and classes?
Milestone 1 and 2 with objects and classes. Milestone 3 is basically approaching like a working beta, like you're finalizing everything.
Okay.
You'll have objects for your monsters, your character. You'll start putting in like weapons or something in the dungeon, treasure for the character to find, some kind of like loose inventory system. There's 1, maybe 2 milestones left. It's very up in the air right now because I'm kind of figuring it out as I go.
What would the last milestone include if we had
Error
one?
handling.
Oh, okay. Like try catch?
Yeah.
Okay.
I mean, really, try catch is just one of those things of like, at this point, I'm expecting a final. At that point, I'd be just expecting a final product. I would just ask you to like audit your code and see if you can make use of error handling instead of having some like very. Sometimes you'll notice when you guys ask me stuff like, "Hey, how do I check if the user gave me output that I can use?" One easy way to do that is with try catch, and then have a try catch block be in a loop. And then, depending on if it succeeds or fails, we continue or break. But the problem is, technically, because we haven't taught it to you, I can't have you use it in your projects yet, but it would make a lot of your assignments way easier and make your logic way less contrived if you could just use a try-catch block. But, that's neither here nor there right now. Is this making more sense? Are you guys feeling a little more confident of what's expected of you? Okay. Cool. I'm glad it helped. Let us talk about what we have this week, which is we're going to talk about classes. I'm going to delete this, delete all of this, and we'll start a new. Okay, make a new file, new package, I'll call it pets. And inside of it, I'm gonna make a couple different pets that we might have. So we'll have cat, we'll have, dog, and we'll say bird. Okay, here are 3 different pets that we can have. And one of the things, and I'm actually going to go to the whiteboard for this. So let's talk conceptual before we get into code. I want to write a program that I can model my pets in. So why do we use classes? Classes and objects. Classes and objects. What are these used for in Java or in programming in general? Why do these exist? Aaron, that's very good. They're blueprints. They're blueprints to describe real world things in a way that we can model them in a program. They're blueprints for modeling real world things. That's pretty good. That's very good. So what are two things that classes and objects have? Classes and objects can be described using two things. What are they called? What do you guys think they're called? What tools do we have at our disposal to describe objects? Classes and objects. What are the two things we've learned about using so far that can describe classes and objects? Methods, yes. Arguments would go under methods, but you're kind of close on something there. Anthony, not quite what I'm looking for with constructor. Methods, and what else? What else have we worked with? Data types, yes. Methods, and we'll call it data fields. Yep, data fields. Oftentimes, we call these things states and behaviors. If we think about real life stuff, we can describe most things by their states, what they are, and by their behaviors of how they act, how they work. And this is really the fundamental thing to all of object-oriented programming is states and behaviors. Once when you understand that, you'll get it. So for instance, if we go back to the pets, our dogs will have like a name. They'll have a name, they'll have a fur color, maybe they'll have a breed, then they'll have an age, right? And they'll be male or female. And then their behaviors will be stuff like they can bark, they can run, they can dig, right? So we can create methods that capture barking and running and digging. And then we can have these variables here that describe things about this specific dog object. So what I'm going to do with these pets things is I'm going to write out a list of states and behaviors for each animal, and we're going to model that in Java. So let's do some brainstorming here. So we've got let me clear all these drawings. We got our cats, our dog, and our bird. And I want some states and behaviors for each. So we got our states over here and our behaviors over here. So let's start with cats. What are some states for cats? What are some, let's try to come up with 3. Sure, instead of the breed for the cat, I'm just gonna say the fur color. Fur color, you'll see why here in a second. Okay, what else? Their age, and one more, their name. Cool, perfect. And then let's come up with 3 for the dog. We'll say breed is 1. And what else? What are some other states for the dogs? Sure, a dog will say each of these have a name. And we'll say size, sure. And lastly, for the bird, our bird has a name. And they'll have an age, let's say. And let's have one more descriptor for the bird. Oh, we'll describe its sex. Is it male or female? Behaviors for the cat. Let's have 2 for each. So what are some things that a cat can do? Yeah, a cat can scratch. Sex is binary, yes. Sex is binary, gender is something else. That is literally the biological scientific definition between the two terms. Don't bring that shit in here. Don't try to get me with that shit here. And they can also sleep, yes. What about dog? What are two things that dogs can do? Bark and bite. Awesome, I like it. And what about a bird? What are two things that a bird can do? Fly and sing, we'll say. Yep, cool. So we've got our models here that we want to create, and we'll do them. And then let's model these and we'll talk a little bit about the driver class. While I'm here, never mind. We'll talk about static here after all this. So let's go back to our code and work towards creating that. So for our cat, we said our cat had a string name and fur color. And I believe we also said age, right, for the cats? So there's a states for the cat. Let's talk about the states for the dog. We had a string name, breed, and then we had an int size for it. And for the bird, we said he had, let me go back to the, does anyone remember? We said they had a name and sex, right. And we'll say Boolean is male. And then what was the other one for the bird? Did I say age? We'll say, well, no, that was a behavior, not a state. And just for the sake of using different data types, we'll use double height. And we'll have this be in centimeters, just because. Okay, so let's talk about some of the behaviors. So these are our states. And let's talk about some of the behaviors that our cat's gonna have. What do we say? We said our cat can scratch, and we said our cat can sleep. In this case, I want to say public void sleep. And we'll just print out our cat's name, and we'll say our cat's name is sleeping. So we'll say snap print name is sleeping. Public void scratch. And we'll just say for this one, we'll give a string object. So here's the thing that they scratched. Just and we'll say our cat has scratched, and then object, whatever the thing is that our cat just scratched. Cool. And we're going to do something similar for the rest of our. Oh, are you guys able to hear the sounds? Hold on. Okay, now you shouldn't be hearing the Discord sounds. I don't know who the hell is pinging me on there. But I do want to double check because there were some group members who were having questions. Oh, I'm being invited to play Among Us. Damn it. That sounds so much more fun than this. Time to end class, yeah, exactly. Hurry so I can play. Let's have our states and behaviors here. Public void, we said they can bark. I'll say name. Oops. Goes bork bork. Public void bite. String object. Just keep forgetting I can do this much faster. Name as bitten object, just because a bad dog. And then for the bird, what do we say that the birds can do? Does anyone remember? Ha ha ha, Matthew, we will get to that here in just one moment. Fly, okay. Public void, fly, snap print, name is flying, and then public void sing name is singing a song. Cool. Okay, so Matthew asked a very good question about why we are not putting static. And the reason for that, sorry, I was reading what Juvenal said. What Juvenal said is pretty correct. The reason why we're not putting static in these is because, first off, we're not accessing them directly from a static context anymore. So I'm going to make a pets class. This will be what's called the driver class, because it will have the main method, public static void main string args. I am no longer going to be calling these methods directly from here. I am going to be creating instances of a pet. Let me call this pets. Okay. I'm going to be creating an instance of the various pets that I have and then using the methods within them. So let's go back to the whiteboard real quick and let's talk about what happens when we do that. So I'm going to move the whiteboard over here. Can I move this stuff over? Yes, I can. Awesome. Oops. Let's grab all of this and move it over. So at the beginning of class, someone said the reason why classes exist is that they're basically, blueprints. Sorry, I had to blank that for a second. So let's say we want to create an instance of cat. Well, we have our blueprint for a cat here, and our blueprints have our states and our behaviors. And then when we create an instance of it, we give it a name. So in the code, when we say something like cat c equals new cat, this is an instance of cat with the name c, because that is what I named it over here. Y'all follow me so far? The reason why we don't use static in the methods names anymore is because we want we want different instances of those methods for each different instance of a class that we create. We want those things to be able to be different for each class. And that's more of a higher level concept that you won't see in the examples that we do now, but just be aware that it exists. I'll try my best to demo it today, but it might still be like a very loose thing, but you guys don't need to worry about that too much just yet. So I create instances. I have these blueprints, and I can create various instances of it. So let's say I have, up from this blueprint, I create an instance named C. I create another instance named C2, and I create one instance named Kitty, right? I've created 3 instances of the cat. Each of these have different fields associated with them, or rather states associated with them. They might each have a different name, a different fur color, etc. And we'll see that here in just a moment as I demo it in the code. But this is a very important thing to understand. We're creating different instances. When we have something that is static, static means only one instance of it can ever exist. Only one instance of this object can ever exist, and it persists through the entire program runtime. So a good example that I showed the other class was Java static counter. Where is it? Here it is. So here was a really good demo showing how the static variable works. So over here, we've got a piece of code where we have a class called counter.
We still see your whiteboard.
Oh, I'm sorry. Here we go. So here we have a class named counter. Inside counter, we create a static integer count, which is initialized to 0. And every time we create an instance of counter, we increment that variable. And then we have one method called getCount, which just prints out whatever the value of count is at the current moment. So we create a single instance of counter over here. And when we do that, this thing gets created. Because this is the first time we are encountering the static variable, we throw it on the program stack, or on the runtime stack, excuse me. The runtime stack is the thing that has all of our methods, variables, etc. in the program. And then we increment it. Then we print out, and what do we expect the value to be? Can I delete these? Yes, I can. Cool. I'll delete the comments. Cool. What do we expect the value to be when this prints out? One. Yeah. And that's kind of, it makes sense with what we know about classes so far. Right. So what happens is when we come here and we initialize a new counter, the compiler goes, hey, static integer count already exists on the runtime stack. I'm going to ignore this line because it's no longer pertinent. We already have this static variable in the stack, so I can just ignore this initialization. But it will still interact with the count, if that makes sense. And then when we run this, it should print out what? Two, exactly. And for this one, it'll print out 3. Now keep in mind, it is only doing this because the static variable is within counter. If we had counter in another class with a different static variable, it wouldn't be the same. The static variable would be different. So if count wasn't static, it would recreate count every time. Correct. All of these, like if we remove the static keyword from here and I run the program, it's going to print out 1 every time, right? Exactly as we expected. But if I put static and I run this, it's going to print out 1, 2, 3. The static keyword means only one instance exists. So why do you guys think we use the word static keyword in our main method? Why do you think we use static for the main method? Exactly, we only want one main. For our entire program, there should only ever be one main, one driving force in the program. And that's the same thing here. So, but when we create a new object, so when I say cat c1 is equal to new cats, and we'll worry about constructors here in just a minute, when I use c1 dot sleep, I no longer need this to be static because I'm referencing it from a dynamic object that I created rather than trying to reference the one directly, rather than try to access this thing directly. Now, we're going to talk a little bit about constructors because you need to know that for classes. Let's hop into the cat. So we've got our states and behaviors, and we need a way. We need constructors. The reason we need constructors is because when we call this object, we need to leverage something that can create an instance of it. Now, by default, Java is already pretty good about what's the phrase I'm looking for? Java is pretty smart about creating a default state of your object, but if you haven't initialized any values to these variables, then what's going to happen when you call just a regular constructor is all these are going to be initialized to null, which, as if you guys recall, null is not the same as 0. 0 is still a value. Null means no value. So when you try to interact with these variables, you're going to get errors and your program's going to crash because you can't do things with a null variable. Is everyone clear on that one? Because that's going to become more prevalent as we move forward. Okay, cool. So we have 2 different kinds of constructors. We already kind of talked about one a little bit, the default constructor. The default constructor is what is called when we don't have any parameters. When we just say, hey, create a new instance of this object. Cat c is equal to new cat. That right there is invoking a default constructor. So the way we make a constructor is we say public and then the class name. And that is all that is needed to tell Java, hey, this is a constructor for this class. Now, typically, for the default constructor, what we do is we take all of our variables within this class and we set them to the zero value is what I call it. And also I'm gonna change this around a little bit. I like having my constructors and methods and everything come after. I always like having all my variables at the very top, and then I'll put my methods after all my methods, including constructors, after that. And that's what most people end up doing too. It's a nice way to keep your code neat. So I want to set all these to be the zero value. So in that case, name will be an empty string, fur color will be an empty string, age will be 0. So because these are now in the 0 value and not null, even if I call the default constructor, then my program has a way of interacting with this stuff. Now, you won't always hard code a default constructor. More often than not, you won't be using a default constructor. You'll be using what is called an explicit or parameterized constructor. There's a big clue in the name of why this constructor is different from the default. What do you guys think makes this constructor different? What do you guys think is different about the parameterized constructor than the default constructor? Take a wild guess.
Takes a parameter.
Exactly. It takes parameters. Yep. So we'll have string name, string fur color, and int age. These will be the things we want to have in our cats. These are the things we want to use to describe cat. So if I go name equals name, Java's going to give me a weird look. What do you guys think is going on here? What is happening in this line, do you guys think? Why is Java giving me weird looks? I want my cat to take the name from the parameter. Why is it being weird?
Referencing the parameter.
Exactly. Because they're named the same name, they're referencing the parameter. So we say this dot name is equal to name. Then Java knows I am referencing the name of this object, the name variable of this object. And we repeat that for everything else. Now, some of you might be thinking, well, why not just name your parameter something different than what you have your local variables named? And you can do that. There's nothing necessarily wrong with doing that. It'll work. It'll have your code that works. The downside to that is, and I'll show it right over here. Let's say we name this A, B, C, right? You guys normally wouldn't name your things this horribly, but just for the sake of argument, we'll say that's what we did, okay? If I come in here and I say cat C is equal to new cat, what the fuck are A, B, and C? I'm using your code. I don't know what the hell A, B, and C are. I don't want that. I want to be able to, I want to know very clearly what these parameters are and what they're named. So if I change the name to that and I come back here, then this is a lot more helpful, right? Users of your program will much more quickly and easily be able to just glance at your code and understand exactly what is happening, what these variables are, what they mean. And I name the cat Lucy. For color is brown. Let's just say orange. And then age is 5, 6. Cool. Right. I have a much easier time understanding what's going on. Let's go ahead and make constructors for our other objects, for our other pets. And I'm only going to make parameterized explicit constructors for all of these because we're never going to use the default constructor really. This dot name is equal to name. This dot breed is equal to breed. This dot size is equal to size. And I'll do the same thing for the verb. Public bird. String name. Boolean is male. Double height. This dot name is equal to name. This dot ismail is equal to ismail. This dot height is equal to height. Cool. One thing I also want to demonstrate, in Java, we have different access keywords, right? Access keywords. And they are, I should put all this in one block comment. Access keywords in Java. There's public, private, protected, and then there's the default. Default is just like, this is technically default. This is the blank. Public means anyone can see this thing, can see this object. Or in this case, we call variable, but more loosely, these are just objects or variables. Object or variable. Private, only the housing class can see it. Only the class can see it. Protected means only classes in the package can see it, meaning it's in the folder. And then default means, I think default is the same as protected. Let me double check. Access keywords in Java. Within class, within package. Default, outside package by subclass, outside package. Yeah. Default is nearly the same as protected. The only difference is if you have a protected value and you use inheritance. So, you know, you have, let's say in one package you have, I'm not going to go too far into it because you guys don't learn about inheritance in this class. But let's say you have an animal class in one package, and a different package you implement the animal class in a class called shark. Then a protected variable within the animal class can be accessed by that shark, even though they're in different packages or folders. But don't dwell too much on that right now. Protected and default are kind of very similar for our purposes because we don't deal with subclasses in this class. We don't deal with inheritance. Mostly same as protected. Okay, cool. So this is for the most part all we need to know. So I'm going to here have a private int named ID. This ID value is the, you know, when your cats get chipped, it's going to be that. So that's what this is going to model. When you have a pet, it gets like the digital chip implanted into them so you can track them if they get lost. That's going to be that. Now, if I try to access c.name, I can get it. If I wanted to print out, say, c.name, I can do that. It'll print out Lucy. If I say c.furcolor, it'll say orange. Now, if I say c.id, I get an error. Why am I getting an error?
Private.
Exactly, it's private. Private means you specifically cannot access it. So if we have a variable that's private, how do you guys think we can see the value in? We can see that value. How can I gain access to c.id? Yeah, through a method. Those methods, yep, are called the setter getter methods. Exactly. So I'll just say setters and getters over here. Say public void set ID int ID. Oops. This set ID equals ID.
Why does it automatically correct to set? Like, if you just type in SE or GE, it just automatically knows.
Because IntelliJ is smart.
Okay, I see.
It's just the quality of life thing that IntelliJ knows enough to do. That's why IntelliJ is like so nice for all levels of development. There's so many. It's a great introductory thing because it really holds your hand, and it's great for can't think right now. It's also great for more like as you go along and get better with Java, more advanced developers because those hand-holding things actually become just quality of life things for you. So very quickly being able to like complete setters and getters. In fact, I could even do, like if I didn't have this here, I could say Control N, Command N, and have getters and setters set or a constructor set. It'll generate it on its own. It's great. It's awesome. I use those generators all the time. That way I don't have to like waste time. Even though it just seems like a little bit of time manually coding this, when you're working with so many different objects and classes, it's so much faster to just define the variables and the custom stuff and then let Java take care of all the boilerplate stuff for you. It's awesome. Or let IntelliJ, excuse me, take care of the boilerplate stuff for you. So we have getters and setters. So that here, if you want to c.setID, our cat gets chipped, and we'll put the ID of 2241. right? That'll be their cat's ID. So then if I say system.print c.getID, it will print out 2241. And let's run this real quick. Awesome. Cool, cool. And just I just wanted to demo static again real quick. This is going to be like a really contrived example. It is not a good example at all, but whatever. Static Boolean is feline is equal to true. Let's see what this is by default is true. And I have my cat C2 is equal to new, cat Gary black, and he's 2. Okay, if I say C2 dot is feline is equal to false, and I have 2 print statements here. Print C1 dot is feline. Oops, just C, excuse me, is feline, and C2 is feline. What do you guys think will print here? Let's put vertically. So if we look at this, we got our isCat, our cat method over here. We got a static Boolean is feline. And over here for C2, we set it to be false. And then we're printing it out for C1 and C, or C and C2. What do you guys think will print? True then false? How many of you guys, give me a yes or no on the board. How many of you guys think it will print true and then false? Give me a yes or no on the participation board. Okay, let's do an experiment. We have a very easy way of figuring out what it's going to be. We can just say run. Whoa, they both printed out false. Why did that happen? Exactly, static. Is feline is a static variable. There's only ever one instance of it across all of these classes. I can have like a million different cat instances, but they will all share the same is feline. That is what static does. Now, some of you might be thinking, well, when would I use that? It's hard to come up with an example off the top of your head, but and I think it's better to understand conceptually that it's multiple instances sharing the one cat. So let's go to the whiteboard and real quick and draw that out. Clear all this. So like, let's say I have multiple, we'll put our blueprint over here. We have a circle, and in each circle, there is a triangle. And let's say the triangle has some kind of like color filling. We'll say it's yellow, right? It's a yellow triangle. That's what's initially said. Well, we can create a bunch of different instances of our circle. With different colors for the circle, or different, these different colors represent that these are all unique circles, but all of them, all of the triangles point to the same single instance of this yellow triangle. And if in any of these, we change the yellow triangle's color, so like let's say here in the blue circle over here, we set the triangle to be red. Well, then once when we're here, this triangle, the shared triangle will also be red. I mean, the picture might be a little more confusing than it really is, but this change gets applied to the shared one. So any changes we make along any of these lines gets shared. Does that kind of make sense? But if you put that line 12 statement in 9, then it would print. No. Or wait, hold on. You might be right. Let me go back and look. So you said if I put that line 12 statement in line 9. Oh yeah, if I put that over here, then yeah, it would print true then false. Right. And we can do this right. We can try that right now. It's going to print true then false. Exactly. That is exactly correct, Mikan. And then within our pets driver class, we're just going to have one of each pet. You know, let's just say I have one of each pet. So we'll replace all this. We'll say dog D is equal to new dog Rover. And then we'll just breed. I'll say Mastiff. And then his size is 5. This is just some arbitrary number. And then we have bird B is equal to new bird, Tweety. And then what's next? Is male. We'll say Tweety is indeed a male. And then, oh, you know what? Tweety's a girl. How about that? Tweety's a female. And then what's the last one? Help me out here. What are my heights? Just say 1.3. Just for random's sake. We can say C dot, what are the different things our cat can do? C dot scratch, my arm. C dot, what else can they do? Sleep, you know, our cat scratched me and then he went to sleep. Our dog bark. He barked and then bites. The mailman. And then our bird will fly, and then our bird will sing. And if we run this program, then we can see that for each of these methods, it's got the different bird. So now let's say I have 2 different birds, right? I have Tweety and I have bird B2 is equal to new bird. I don't know, Dottie. Dottie is a boy, or is a male, and then Dottie is also 1.4 centimeters, or whatever. I say B2 doth fly. Let's say Dottie doesn't like to sing, but Dottie likes to fly. Then over here, we'll see the 2 different references of classes. Here's an example of how to basically reference the same method from 2 separate classes. And obviously they're going to be different because they each reference the local name. And when we initialize them, we gave them different names. Cool. Makes sense? Everybody pretty good about objects classes? Any questions you guys might have? No? Okay. Let's talk about what you guys got going for the upcoming week. I am going to have, so for pre-lab 10, I'm going to have you guys do another quiz, but I have yet to write it because I got kind of turned around. This is your section. Yep. I'm going to hide this for now. Hide, and it's actually, the pre-lab work is due next week. So due November 20th. Yeah, I know the due dates are off. But I'm going to hide that for now. You guys don't have to worry about that. We'll just hide this too because you guys shouldn't have access to that just yet. And I don't know when these are going to be due. They'll probably be due. They're either going to be due during the recess or after the recess. I have yet to decide. But for this week, you guys, I'll put out a Discord message once when the quiz is up. Just keep your eye on it. It should be up sometime this weekend. But I will put out a notification when it's out there. Chapter 9 lab. You guys, is this going to the wrong link again? Yes, it is. Lab 9, ATM program. Share. Let's get the URL. Copy link. Edit. Create link. Your ATM program. First name. Last name. Zip. And this is due next week at 12 o'clock. And we are expecting a zip file. Cool. Okay, so you are going to be making a ATM program for an imaginary bank. This bank wants our ATM customers to have 3 different options. They can either sign into their account, or they can see a list of happy customers, or they can exit the program. From the main program, these are going to be the 3 options you present your users. I gave you an example of what the meet our happy customers should look like. So when you print it out, it should look something like this. You're going to basically print it out so that there's only 3 customers per line. We'll get to that here in a second. So first step, and this is kind of my effort to write my labs a little bit closer to how you guys see them in 210. I kind of break up some of the stuff for you guys. Part 1, you guys are going to create a class for your customer. So you're going to create a customer class that has these data fields. Let me close the door. You will have these data fields. Obviously, I have not given you which data type. I think at this point, you guys should be pretty smart enough to understand what data type you should be using. And then that's really it. That is all the customer class needs. The customer class is just used to hold information about each customer. Next, you have the worker class. The worker class is going to be responsible for, I'm blanking right now, sorry. The worker class down here is going to be responsible for doing the work about the customer. So putting money into their balance, putting money out of their balance, showing the user's balance. These are 3 functions that the worker class needs to be able to fulfill. Basically, once when the user is logged in, you will tell them, hey, this user wants to deposit money, or this user wants to withdraw money from their specific account. You have to be very careful to make sure you're only modifying the user that's logged in, and you're only displaying their balance. I mean, if Jenna logged in and saw Barry's account, she'd be a little bit confused, right? Because she doesn't expect to see $800 some in her account. On that note, you're going to have a file called database.java. This file is going to be responsible for holding all of your data in a private array. So you're going to have a private array of 10 customers, these 10 customers. And as a hint, each row represents a different customer object. As you guys can see, the columns are the different fields that you need for the customer object. If we scroll back up a little bit here, you can see that, first name, last name, age, bank account ID, bank account balance, PIN, etc. So I would recommend where you start your program is kind of the same way this flows. Part 1, create the customer class, then build your database class, then build your worker class. And once when you have all the pieces of your project of the program, you can develop what's called the driver class, the main class called ATM program. And that will dictate the main flow of all your program. So as stated in the beginning, we're going to ask the user for one of the 3 options. If they choose to log in, the program is going to ask them for their bank account ID and their full name. Then it needs to search in the database for that. So this is going to be one problem you're going to have to tackle is, okay, I need to access customer objects in a private array. And these are, if we look at these fields, the bank account ID and their full name, depending on what they give, they will they will either be accessing a public field, their name, or they'll be accessing a private field, their bank account balance, or sorry, their bank account ID. Yes, for their full name, bank ID, and then for their PIN. If both pieces of information check out, then the user will be logged in, and the menu options will change to these 4 options. So you need somewhere in your main driver of checking, is a user logged in or are they not? I'll give you a little hint here. Hint, you need a way to check if there is a user logged in. Remember, null exists. This will be a hint for you guys for this part. And then once when you're done, you're going to have 1, 2, 3, 4 different Java files because you have 4 different classes. So 1 class per Java file. You're going to zip all those together and send it to me at iLearn. Something I said in the last class, and I will say it here, please, 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 when you send files to me, when you zip them, do not copy paste the file and then put those copy files into the zip file. When you compress to zip, your OS already makes copies of them on the back end. You don't need to make them. So one student complained that because they were accessing their files, their Java files directly into their IDE, which is not really something you want to be doing with an IDE. They were having problems. But yeah, please, please, please do not copy paste your files and then send me the copies, because your name is going to be different from the class, and that's going to cause compilation errors. And if I can't run your program on the first go, you guys know what happens. You lose half points automatically. So please, please, please don't do that. Any questions on the assignment or what I just said? I don't know if I had problems with you guys in this section with you being able to send out your zips. I think you guys have been mostly okay with understanding how compressing and zips work, but I just wanted to mention that because there were a few students who had problems, and I just wanted to clarify that. All you do to send me a zip file, like suppose these were Java files, right click, compress 4 items. It compresses them. And then you're going to rename this archive.zip. You're going to rename it to like ATM project, and then my name, my first name Turk, last name Erden, and then send that in to me. Cool? Any questions about what's due next week? Any questions about what we learned today? Okay. Well, if you guys are all good, I will stop the recording.